preliminary information here on whatever this is. Where we can see it. So there's some information in here about the number of proportions here. So the short of it is 157, 34, 50, 107. All right. So of each group that had a recurrence. Okay. So it would appear, and I don't know what you selected the first time. It looks like this is the correct answer. Do you happen to know what you selected the first time around?
I think I picked the third one.
Third one. Okay. So I'm saying, 20 and 24 out of 50. They say 50 there and 107, 20 and 24. So probably go with that one for this option here. It's pretty hard to read. They're really making it pretty specific. Now, in terms of the confidence interval, there is a formula for that. So for the difference in proportions. Okay. So that actually will help us to answer this. That actually helps us to answer this. So it's typically p hat 1 minus p hat 2, which in your case is 0.4 minus 0.224. That's the 0.176. So we know we're in good shape for that. And then it's plus or minus Z alpha, which we'll get to for the 95%. And then this is kind of where I always ask you if you have formulas for your tests here. I can pull up the formula if you do not have it.
I think I sent it to
Go with so it's a pretty basic formula, but it's p hat 1 minus p hat 1 over n1 plus p hat 2 1 minus p hat 2 all over n2. So in your problem, it could look a little overwhelming. We know the information from up here for p hat 1 and p hat 2, and then the n's are the denominators. So kind of maybe looks worse than it actually is, but it's get some more room here. Kind of squeezed all this in here. It's quite the calculation.
yeah.
So plus or minus 1.96 square root 0.4, 1 minus 0.4 over, and then n1 was 50 plus 0.224, 1 minus 0.224 all over 107. You grab your favorite calculator if you want. I'm going to calculate here for us as well, and we'll see which of these numbers we get. There's no way to know without doing the calculation. It's just the way it is. So 0.1571 is what I got here, which is the second answer, it looks like. All right, let's look at the null and alternative hypothesis here. So it says the treatment group has the lower rate of recurrence. So that means the treatment group will be less than, I guess, the control group, PT, PC, with the hats there. I don't know. This is the null hypothesis. There's no hats. That's the difference. So you can see actually there's two answers that look good, and the only difference is that hat. So it ends up being the one without the hats because there's no hats in the proportion hypothesis test. It's just a little wrinkle for that type of problem.
So when is it when it's the hat?
The hat is for the estimate, the estimator. So we use the estimator here for the confidence interval. But when your hypothesis test is always on the population,
Okay.
whereas this one is a statistic.
Okay.
And so that's the big difference there.
Okay.
Okay, and so then the test statistic, the these are the options for the test statistic. So let me go find the formula for a two proportion test statistic. All right, so the formula here isn't all that, I guess, that easy to understand, but we'll match it up here. So it's going to be the 0.4 minus the 0.224. We've been doing that a bunch. That's leading us to this one. And then the rest of this, actually none of these are. Oh, I'm sorry. That is not correct. They the pooled, they call it a pooled proportion, which is what we're doing in this problem. This comes from this p hat really is the adding up of like 20 plus 24 over 50 plus 107, which ends up equaling the 0.280. So it does end up being A.
A.
Yes. All right. And then the last question there, last question 5. So they give you the test statistic of minus 2.29. You've got to find the area in the left tail. So you can go to your favorite statistical package if you want, the calculator, table, whatever, and calculate this. Mine is loading up now. We'll do that later. All right, so it ends up being 0.011, which is between 1 and 2%, like that.
Okay, we passed. Okay. This one has more, it looks like. Are you
All
there?
right, yeah. Yep.
Uh, yeah.
If you could scroll down a little bit for question 1, get that fully framed so I can see that. All right, got it. Going down to question 2.
The same stuff from before. Or similar.
All right, got it. Going down to question 3. right, got it. Gonna go down to question 5. Question 6. Question 7. So I can get all that. Got it. All right, let me get that top part on section 2 first. All right, if you're gonna go down to question 8. I'm gonna go down to question 10. All right, keep going, question 11. All right, keep going down for the next one. All right, perfect. You can get all that. It looks like there might be one more choice. Yeah, well, that one isn't the answer. So let's keep going. 13. Scroll down just a tiny bit more. Let's get that last. Yeah, there we go. All right, got it. If you're gonna go to 14. Okay. All right, I will share my screen here and look at some more questions together. All right, so there's kind of this preliminary information. That's not what we want. They give you this preliminary information at the top. They tell you that out of 200 students, 142 said yes. Now, that actually is not what is needed for the null and alternative hypothesis. Null actually refers back to this, like what they believe to be true, which is 2/3. So you're looking for the only one that's 2/3. But then just the other one here is that we're also looking for whether well, it says greater than. There should be some language in there that says like it's gotten better or worse. But I didn't see it in there. Now, question 2 kind of already alludes to, we already alluded to this, that this p hat is x over n. And so then they want you to find the test statistic, the z. So there's again formulas for all of this. If you don't have that formula sheet, you'll want to, look at it at some point. But
Okay.
I'm going to grab it now. All right, so the formula here is z equals p hat minus p over p times 1 minus p over n square rooted.
I have that one.
In your problem, p hat is 0.71 minus 2/3. 2/3, 1 minus 2/3 over 200. Square root of that. And that's your answer. So we just got to grab a calculator and see what we come up with. All right, so I got 1.3. Exactly, which is kind of neat.
Positive.
So now, yeah, the positive one.
Okay, it can never be negative, right?
No, it could be. It could
Oh,
be.
it can.
It's just based on the test. Since it's the alternatives are greater than, it's typically gonna most often be a positive number there. So now the p-value, we got to get the p-value. So that is the area. I'm sorry, they give you the p-value close to 10%. So what conclusion can we make at 5%? So the you can reject at 5% because it's a smaller alpha level. So that would be the first option there. Okay.
Mm.
Moving along here. All right. So it says here, what is the best estimate for the population proportion students are likely to eat at the new dining station? It's that 142 over 200, which is the 0.71. It's the p hat. It's this idea of there being an estimator.
Nurses don't do this kind of stuff, do they?
I
Please
sure
tell
hope
me.
not. I sure
Oh,
hope not. Want my nurse doing any of this. If I'm injured,
huh?
or the doctor. Don't want the doctor doing this either. Um, yeah. So the sample error, we actually, it's what we just did. It's that p hat 1 minus p hat over n. So it's that 0.71, 1 minus 0.71 over 200, which is this last option here,
Is
I believe.
is this more like public health engineering or not public health?
Uh, well, I mean, they apply it to all the sciences, but I mean, nobody, I mean, I've never met anyone who's done these calculations in practice,
Oh, okay.
only in research typically are
Oh,
these
research.
applied.
I was like,
Yeah.
like what is this?
And then I get the call, hey, I got some data I need to ask. I said, okay. So they're not even doing it. They're paying someone else to do it. Um,
Oh,
so.
that's crazy.
All right. So they give you the 95% confidence interval. They give you the 90% confidence interval. Um,
Oh wait,
so
you're at 7? Hold on, where am I?
yes. Yeah, it's
Um,
6.
We
You have the
skipped.
answer done.
That's 5.
Okay, let me grab the confidence interval calculation. All right, here we go.
I think we skipped 6. You're missing. Oh, there it is. Yeah.
All right, so for number 6, 95% confidence interval is consistent for one-tailed test. Nope. So confidence intervals are, oh, I see what they're doing here.
Isn't it usually like 5%?
So there's 90% here, 5% here, and 5% here as an example.
Uh,
Um, and so as an example, and if it's a one-tailed test with a significance level of 5%, that's the one that matches up here with 5% being in the tail, without going into more explanation on that. Um,
okay.
so let's go to question 7 here. So main idea of the confidence interval is that it gets wider as the C value increases. So as C increases, the width of the confidence interval gets bigger. The question is, does it contain that 2/3? Do either of them contain that 2/3, which is 0.67? They actually both contain it. So we would go with that second option there since they both contain it. So the next grouping of questions is more like the previous assignment that we did. They give you two proportions here, in this case, women and men. They're told for something, who knows what. But we're going to be asked to do a bunch of things here. So the first thing is to estimate the difference in the population proportions. So that's like P1 minus P2, and we have those values here. It's 0.572 for women,
Mhm.
0.431 for men, which is 14.141. And so women are 14.1% more likely than men to say that their pet is a member of the family at the same level as a human.
So it's more
Looks
likely.
like the women are the bigger of the two groups. Yeah, 57.2 versus 43.1.
Okay.
Okay, 9 is kind of unrelated. It's kind of off to the side here. They're saying for a 99% confidence interval
Hmm.
that there's a 0.005 in each tail. And so you can look up the Z for that. It's going to be this third one here is the correct uh, Z score corresponding to those areas.
Did you have that memorized, or you just looked it up real quick?
But no, well, I do know it, but it's bigger than these two are way too small.
Uh,
But
okay.
yeah, it's 2.58 is the standard one.
See how smart you are?
Well, you see stuff over and over again, it gets a lot easier to remember. All right, we got number 10 here. We actually did this in the previous problem, our homework set, although this instructor formatted the answer slightly differently. We need to go back and find our samples. So it's 250 for women, 225 for men. So this third one here has the right sampling for women and then for men, along with the correct values.
SE
So
is that sampling SE, or am I
this is the standard error. The N is the number of things
standard
sampled.
error?
This is yeah, it's just the standard name they give to the error of the estimate
Okay.
for a confidence interval.
Sometimes I get mixed up with all the terminology.
Yeah, there's a lot to remember here. It can be overwhelming. All right. So they're saying, hey, here's the confidence interval. Here it is right here. All right. How should they in uh, so the answer, like, it's a standard language that they're looking for. It's actually, we are 99% confident that women are between these two percentages that are given, more likely to say their pet is the same level as a human compared to men. It's the standard language of you basically repeat what is in the null hypothesis. Um, you can see that B says men instead of women, but it's the women that favor the pets, at least according to this study. All right. moving on here to number 12. All right, so it's kind of the same deal. Women and men, member of their family. We believe that women favor it more than men. So we're looking for that one. So you'll see that that's this one and this one. The bottom one here, though, is a statistic. The other one's for a population. Null hypotheses are always on the population.
Are you missing one? I think you're missing, but I think you're missing an option, but I don't think it's that one anyways.
Yeah, it's not needed.
Okay.
And so then for 13 here, 13 is the formula for a for two sample here. This is 5. So this is the only, I mean, we did this in the previous assignment. It's the same formula. It's p hat 1 minus p hat 2 over, and then you use this p0 in the bottom, the new ends. Just lining up the formulas when it's multiple choice like this. So then the researcher, 14, researcher gets a pretty small p-value, 0.002. That means that they will reject the null hypothesis. It's pretty small. It's probably going to reject in all cases. All right. Let's see how that goes for you.
86. So let's see which one we missed.
Yeah, let me know which questions to look at again.
I think it's question 3.
Okay. Sorry. That is apologize. That is the second one.
A second. Okay.
Yeah, the fail to reject the null hypothesis.
And then I think the last one is 12.
So let's go with this other one. Maybe oh no, sorry. And I see what the issue is. That is not correct. Different. Sorry. Different. No, that is actually this one right here.
See that there's another one missing like that.
Oh, that's right. You're right. It is that bottom one then. That one that says not equal to.
It's the bottom one.
Yeah, without the
Okay.
hats.
Okay, hold on. Let me restart it because it's not showing me. Three. So we said it was fail to reject.
I don't
And
know which is a 3. Yes, 3
yeah,
is
we change it to fail, right?
yes, fail to reject.
Okay. And then 12 was the last one without the hat.
Yes.
Okay. And it's not equal to, right?
Yes, not equal to.
Okay. All right. Yep. You're right. Okay, so I don't know what happened. It seems like something got dropped off because there was like there was like 5 assignments, and then I'm going in there now, and then I don't know what the hell happened. I don't know. He moved the chai square.
Chi-square, yeah, maybe got pushed out to
Yeah, he pushed it out to next week. So, and honestly, I haven't looked at the R lab. I don't know what's in there. I mean, that's the only one that's left.
Yeah, we got some time, we wanted to look at it and we can I'll I can reschedule that time later today for another day whenever you're ready to use it.
Well, I have to do it today.
Okay.
Um,
Well, we can look at
I
whatever you would
don't
like.
know what's in there. That's the thing. I haven't looked at it. So, okay. All right. Here we go. Can you see it now?
Yeah. All right. So let me grab a snip of this. All right, you can go down to the next question.
One.
You can go down to two. Number three. Okay, got it. If you want to go down to five. All right, scroll down to number six. I got seven, so we're gonna go to eight. Nine. Let's see here, get nine. And then 10. All right. So I'm gonna actually just do this in Excel and we'll be able to do all of it without any uh any issues there. So just give me a moment here to get the data entered into Excel.
Okay. And then can I just run out real quick and come back in, grab my
Sure.
phone?
Yep. Sounds good.
Okay, I'm back.
All right, so the first thing that you do with a problem like this is you enter the data, whether you're using R or whatever, but you just enter the data, and then you can calculate what's called a correlation coefficient from the data set,
Is this like
which I
the
will,
XY thing or no?
yeah, yeah. So the correlation value ends up being negative 0.9363, which is pretty strong, but strong in the negative direction.
For the last one?
Yes. So that would be the answer there. The next thing is to write the equation
How do you know
of
if it's strong negative or moderately negative?
the teacher should give you a guide, like if it's like minus 0.3 to minus 0.7, maybe they have an obligation to tell you
Okay.
what they're using for that language, if if they are or not. So now Because of the negative correlation, it's gonna have a negative slope, which means that that one is out. And then you can actually calculate the x slope and the intercept in the same way. So give me a moment here to get that slope. Slope ends up being minus 9.0. Yeah, so this is the correct equation.
First
You just
one.
calculate, yeah, the second one.
Will you show me on there how to do that?
I
Will you
mean,
write-
it's the formula here. So you just calculate the slope in Excel like that. That just does it for you.
'Cause I can't see you.
Right, I'm just giving you the formula.
Oh,
That's all I
oh,
mean. That's all it is. And then it gives you this number, minus 9.
oh,
And you
okay.
can do the same thing for the intercept. The same idea here as slope. Let's see if so. Yeah, here's the formula for that. And so, you know, these numbers, it gives you minus 9, and this one was 89.1, like that. So, okay, question 3 is, so with variability, they're asking about what's called R squared. You already found that R is negative 0.9369. So you just square it to get the R squared value,
Okay.
and it's gonna be that 87.8 probably. And yeah, that's what it is. All right. So the next problem actually uses this equation we just found here. So I'm gonna grab that equation. Grab another snip of the actual question. All right, it says, what is the predicted math score when the LSD tissue concentration is 5? So this is, they're putting 5 in for that right there. 89.1 minus 9 times 5 ends up being 44.1%, like that.
I can't see your screen though, but I can
Oh,
hear you.
okay. That's right. I'm not sharing. Okay. Yeah, I've been sure thought I was sharing for a while here, so
It's
you'll
okay. I'll go back and look. It's okay. I was listening to you.
so like you said, strong negative correlation. The number 2 is the second one here. These were the formulas in Excel to get those. And then for number 3, you're just squaring the R value,
Picked the
get
wrong
87.
on question 2. I picked negative. Oh, see, I picked the wrong one. Okay. Picked -9. Okay. Okay, got that.
And then this is just putting that number in for X. Okay, for number 5 here, the null hypothesis always refers to betas, and this is the only one that it could possibly be because the equality has to be in the null. So that's the only possible answer. So for number 6, you're actually going to do this in software. Um, we can sort of do it without it if we had to because of the degrees of freedom, but Excel has this built in as well. So we're going to do is do that on the other screen here. I'll snip in the results. So this can be a little overwhelming to look at, but it's not as bad. Oh, that didn't work out very well. It when you know what to look for, it's not bad at all to look at. But let me grab a snip of it. All right. So for this question, what they're asking for is the t-stat of the LSD, which is right there, the minus 5.99, right there. See, next question, p-value, 0.0 is consistent. Yeah, we got the same p-value. Okay. So the p-value is pretty small, 0.00185. And then so that means that the like the model is significant. And so there's like a few answers we can get rid of. But this is the one that we're mostly looking for here, if it's significant. And then for number 8, so your p-value is 0.00185. This is less than 0.01, which is your alpha. So you reject the null hypothesis. Uh, it is different than 0.
Okay.
You'll see that this table also gives a 95% confidence interval, which will compare to the answers here. It ends up being that second one there. That's in the table right here. And then finally for question 10 here, it's always we are, which is the first one there.
We are.
We are.
Oh, that language. Okay, let's see what we are. Oh, we missed 2, I think. So the first one, question 1, a strong negative. So you think it's a moderate negative, maybe?
You chose the last one here for sure.
Yeah, I put strong negative. And then we,
I don't know. I mean, it's pretty close to a -1. I guess you could go moderate negative, but
and then we missed number 3.
did you choose 87.8?
I did.
Okay.
Oh, wait, hold on.
It looks like, I mean, I don't know. I mean,
You know what? I think hold on. I think I'm wrong. Hold on. Let me go back in because it's being weird. Hold on. I'll be able to tell exactly which ones. It's kind of hard to tell from here because that doesn't make sense. Okay. Go back to home and do it that way. And I can clearly see which ones. Oh, just one. Question 1.
kind of odd. I mean, I could see a
Oh
scenario
no,
where,
question 7. Question 7.
okay,
7, sorry.
all right. So it was not, you chose A for sure for each.
Mm-hmm.
Oh, I can see why that's wrong. Sorry. Yeah, that is wrong. Um, we really have, yeah, so it's this third one.
I think it's the third one.
Yeah, I guess. It's written, these are written all kind of oddly. It's
I'm gonna go for the third one.
all right.
And let's see. 1, 2, 3.